Okay, now I want to do a case study of big data and machine learning being used in a public policy setting. And in this case, we're going to look at the Allegheny Family Screening Tool. Allegheny County is the county that includes Pittsburgh, Pennsylvania, so a relatively large Midwestern city. And what I really want to bring out in a lot of this is we tend to treat the math as being somehow objective, but what math we do and why is actually a matter of opinion. So I really like this way of putting it from Kathy O'Neill, who wrote a book called Weapons of Math Destruction, that really started a few years ago, helped start a bit of a conversation on ethics in big data to some extent. And she says models are opinions embedded in mathematics, right? So like we have opinions, we build a model, the tool we use is math, but these are still, in fact, models that we choose how to make. So Allegheny Family Screening Tool is something used by the Office of Children, Youth, and Families, and the goal is to determine which reports are most likely to be child abuse or neglect. And I'll mention about 3/4 of investigations are about neglect, and of the two between abuse and neglect is slightly harder to define and make determinations of. So this is built on top of a database that was created in 1999. It's got 1 billion records, which is an average of 800 per county resident. There's 29 different programs in sending extracts. So this is stuff like the unemployment office, the local school district, housing authority, police, the jail, drug and alcohol services, and it costs about $15 million a year to run, which is about 2% of the budget. So historically, this starts in New Zealand with a team of academics. It's a predictive model with 132 variables, and these variables are stuff like how long someone was on public benefits, if they were involved with the child welfare system, the age of the mother, is it a single parent, mental health, and correctional history. The self-assessment of the academics was that the accuracy is fair, approaching good, but New Zealand wound up shelving it due to public objections and new social development minister. And it went live in Pittsburgh in 2016 on the 1st of August. Okay, so it's step 3 in a 3-step process. First, they say in the intake, it's does the situation meet Pennsylvania's definition? Is there present or impending danger? And then they get a risk score based on family history. So ideally, the screeners are going to be able to say, well, the model is just telling me about the history. It's not actually telling you if it's abuse or neglect. It's telling you about the family history from the database because that's the data it has access to. I meant to say at the beginning, this case study is taken primarily from the book Automating Inequality. Although there are a few other sources about this model. It's been written about a few times in places like the New York Times and presumably also some in the local papers, although I've only actually seen the national articles. I suspect that this is not how the model actually gets used because there is a tendency that I talked about at the top to sort of defer to machines, which can seem a bit more neutral and more objective. Okay, so you've got a lot of choices in building the system, and I'm going to talk about all 3 of them. You choose what outcome variables you're going to look at. You choose what predictive variables are going to go into your model, and you choose how you're going to validate the system. So there's a few possible metrics here. We could use actual fatalities and near fatalities of children, and thankfully there are not enough of those to build a model on that data, right? That's helpful. We could use when child, youth, and family services, or county youth and family services substantiate child maltreatment. But they apparently also use substantiation in some cases to gain access to food stamps or affordable housing, going back to the point that it's important to know the system and not just like take the data and do math on it without knowing what you're doing. So instead, the system uses 2 proxies. A re-referral, like if a call to a hotline is screened out but there's another call within 2 years, or if the child is placed in foster care within 2 years of the call. So that's what the model is actually predicting, which is a bit different than directly predicting abuse or neglect. because it's not a direct prediction of child harm. It's a prediction of like what the county will do in terms of foster care or what the community will do in terms of calling. How they do this prediction is stepwise probate regression. I'm going to go ahead and say this is not the best way to do this sort of model. But again, not a stats class. The main point here is that this isn't a causal model. It just makes the prediction. It's not showing that any of these background factors actually like cause child harm. It's just saying they're associated with it in some way. The model was tested on a bunch of referrals using data from 4 years between April 2010 and 2010, or 2010 and 2014, and it is 76% accurate. The author of Automated Inequality is rather skeptical. Note, she says, the AFST has inherent design flaws that limit its accuracy. It predicts referrals to the Child Abuse and Neglect Hotline and removal of children from their families, hypothetical proxies for child harm, not actual child maltreatment. The data set it utilizes contains only information about families who access public services, so it may be missing key factors that influence abuse and neglect. Finally, its accuracy is only average. It is guaranteed to produce thousands of false negatives and positives annually. Okay, so let's talk about some of the problems we get here. The data warehouse, first of all, only has data on public programs, not private ones. So if you seek public assistance, you'll wind up in this data on family history, which might penalize you down the road if you're under investigation. But if you're wealthy enough to afford private resources, private childcare, your own groceries, private mental health services, etc., then you won't wind up in the database, even if you were getting similar services. There's also the problem that like the Youth and Family Services has two sort of contradictory roles. One, they're supposed to provide family support, and two, they're supposed to investigate maltreatment. There's also an issue of bias in terms of the referrals. So like communities are more likely to call about non-white families. And one of our proxy outcomes is referrals. So that builds in a racial bias in terms of like the outcome variable that was chosen. And really quite a scathing review here is the book suggests that in a nice turn of phrase, the model confuses parenting while poor with poor parenting. Essentially because poor people are more likely to have to undertake activities that wind up in the database and thus to get flagged. And there's a cost here to these errors, right? So like opening an investigation is intrusive, it's a frightening event. There's the possibility that it actually increases social isolation or material deprivation and wind up increasing the risk of child abuse. And in particular, of course, the model itself, once we are looking at these outcomes, we don't really have a good feedback loop because remember, one of our outcomes was, say, being placed in foster care, which is more likely if the model gives you a high score because the model score is now part of the thing that leads to someone potentially being placed in foster care, right? So you've got like a self-fulfilling prophecy going on, which eliminates our ability to actually update our accuracy numbers for the model itself, right? So there's a bunch of choices that have been made here. And then we get a number, and that number looks objective. That number is not objective. Now, is that number potentially better than the subjective decisions that were made before? Possibly, right? My point in making all of these criticisms is not to say that it's like bad to use data or bad to use machine learning when you make decisions. Indeed, like I think it is good to use data in making decisions because of the fact that it can lead to better consistency and less bias in all of this. The point is that it does not automatically do that, and you need to understand what your data is doing. The other thing I want to point out about this is like the way it was implemented is generally pretty good. Like the tool design process was open and participatory. The implementation was thoughtful and slow. The goal here was relatively modest. It's an input into what is still a human decision. It's not a decision itself. But we don't have a way to really figure out ongoing performance because of that self-fulfilling prophecy problem I was just talking about. And obviously, like, there are still real problems here. Okay. I'm going to, as usual, post the discussion questions in Canvas for us to talk about.